NFAs. NFAs, right? Little announcement, just so you all remember. Tuesday is all remote, all the time. So don't come to class on Tuesday. I will be at home. I guess you could come here and tune in all together if you wanted to, but I don't recommend it. Okay. So an NFA, remember the difference between DFA and NFA? NFA can have several outgoing arrows from any state. And it can also have what we call the Epsilon Transitions, which are transitions which happen even when you don't read any letter. For example, something like this is an NFA. You'll notice, for example, since there's no outgoing B arrow from the starting state, it's possible to just get stuck on certain strings. Like, there is no way through this diagram if the string is BB, for instance. Your interpretation of that is the string BB is not accepted by this NFA. The things which are accepted are just all strings which can somehow be read in a way that ends in the accepting state. So this accepts anyone want to say, can you say what kind of a string will be accepted by this machine? Yeah.
At least one A.
Okay, it definitely has to start with an A, right? And then what else? Starts with an A and ends with a B? Yeah, although it could just be A. Like that is acceptable also. Yeah?
Doesn't it have to be only one A?
Yeah, I think it should start with an A and have only one A. You can't do more A's after that. Yeah.
Is it A, B to the end?
Yeah, it's just a single A. Turned off. A followed by B to the N. I think that's the simplest way to say this. All right? It must begin with an A, and then if you want, you can do some B's. That's it. Great. This is a typical example of an NFA. Let's talk about the formal description of an NFA. This is going to be very similar to DFA, so it's not we spent like a week before we got to the formal description of a DFA, but we might as well go all the way with the NFAs because it's very similar to what we talked about already. So, formally speaking, here I'll write this like a definition. An NFA is, again, a 5-tuple, and it has more or less the same ingredients. Like an NFA still consists of states and arrows and all that, so I'm going to write, and we use the same notations for all of this. Oops. So it is Q, sigma, delta, Q naught, and F, where Q is a set of states and it must be finite. So Q is a finite set of states. Sigma is a finite alphabet. Delta is a function. Now, here's the first difference. The domain and codomain of delta are a little different. And I will refresh your memory from DFA. In the DFA, the delta goes like this. Q cross sigma to Q. And what this means is the things you plug into delta look like pairs. You know, the typical way you would write this is something like delta of QA, maybe Q1A equals Q2, right? This is a typical way that you would write what the delta does. And what all of this means is the domain is Q cross sigma. That is, the domain consists of pairs, where the first thing is a state and the second thing is a letter. and then what comes out of it is a single state. All right, so the codomain is Q. Now, the delta in an NFA is different. What's different about it is, actually there are two important differences. I was going to try and go sort of by analogy with our previous example, although the previous example is not terribly interesting in the sense that I wanted to indicate. Can I just draw another example right next to it? Just for the sake of illustrating. And I'll have... Okay, so I added a few extra arrows here. Here's what I want us to look at, and let's say the first state is, let's say, S and T. Oops. In this diagram, what would you say is delta of S comma A? Here we will get at exactly why the delta for an NFA behaves a little bit differently. Yeah. Yeah, it could be S or it could be T. So how are we going to write that? I mean, there's a few different ways you could think of writing that. Our solution is going to be, in an NFA, the answer that you get from delta is always a set. It's not a particular state. It's a set of states. All right? And it could even be the empty set. In fact, in this example here, I believe delta of T and A is the empty set. That means there are no arrows from T which use the letter A, right? So, first big difference is this delta here in the NFA, the answer is not a single state, but it is a set of states. And so, what I'm going to write here is delta as a function. Now, the domain is slightly different also, so maybe leave a little gap there. But the codomain here, I want to say the answer for a DFA, it looks like this. The answer is a single state. Here I want to say the answer is a set of states. So what I need to write here is the set of all sets of states. This is a little weird, but it is something that you talked about in your discrete math class. Does that sound familiar to anybody? The set of all subsets of states. That's called the power set of Q. This is the power set, and it means set of all subsets of Q. All right? So what this means when I put it as the codomain, it means the answer that you get from delta is a subset of Q, which is what we want, right? You can see in that previous example that I mentioned. It could be this is a subset of Q, or this is a subset, right? And it can be the empty set if you want. Okay, one other difference, and that is the domain here, which I left a little gap here. What is the domain of delta? It's still a pair. You can see in these two examples. It's still a pair of something. And the first thing in the pair is a state, so it's still going to be Q cross. Now, what's the second thing in the pair? In a DFA, the second thing is always an alphabet symbol. Actually, there is another thing that it could be in an NFA, because NFAs have these epsilon transitions. So it's also true in this case, delta of T and epsilon is S. Right? Because this NFA here has an arrow labeled epsilon. So the fact is, in an NFA, the arrows are not all alphabet letters. They are alphabet letters or possibly epsilon, right? So we need to, instead of the sigma here, which is just the alphabet letters, we need to say anything which is an alphabet letter or possibly epsilon. Unfortunately, it looks a little weird, but the simplest way to write that is like this. Sigma union the set containing epsilon. So this says delta in an NFA consists of pairs. Pairs where the first thing is a state from Q, and the second thing is either a letter or epsilon. And then the answer is a set of all subsets, or is a subset of Q. All right. This is fairly weird, set theory gobbledygook from a certain point of view, but I'm trying to be formalistic about it, at least for today. You know, we don't usually think about things like this. Usually we just use the diagram and everything works out fine. But at least for now, I want to talk about this. Okay, can I just describe the other ingredients of the definition? That was only the first three parts. Okay, and then Q0 is an element of Q, is the starting state. And then F is subset of Q, is the set of accepting states. No funny business there. All right. Any questions about all that? I want to do an example. Typical example is, you know, like the one on the quiz. I could give you the formal description and then say, draw me a picture of this, or we could go the other way around. I'll give you the picture, and you draw the formal description. Let's try one like that. I give you the picture, you tell me the formal description. Here's an example. How about, I'll call these states Q1 and Q2. How about this? Can we write the formal description of this one? So this is M equals, or N if you want, whatever. First, I want the set of states. You working? Should I go back a little? The set of states, what's that going to be? Yeah. Yeah, it's the set of Q1 and Q2. Great. Next is the alphabet. What do you say? A and B, yeah. I'm glad you didn't also say epsilon. Even though you can see epsilon is one of the labels on the arrows, epsilon still does not count as a letter from the alphabet. It has a special meaning. It means the empty string, right? So that's not another letter. That's just part of the, means the empty string. Okay, then delta, which as usual I'm going to describe later on. Then the starting state is Q1. And then the set of accepting states is just the set of Q2. Make sure you put it in those curly set brackets in that position. All right. Okay, and then I have to say where delta. And now we got to give all the values of delta. So I'm going to begin with Q1 comma A, delta of Q1 comma B. And because it's an NFA, I also need to describe delta of Q1 epsilon. All right. What do you think? What is delta of Q1 and A? What I'm looking for here is the set of all states that you can get to if you start in Q1 and you do A. Yeah. It would be the empty set. Yeah. Thanks. That's because, come on now. That's because there is no outgoing arrow with an A on it, right? From state Q1. So there are no states you can get to from Q1 if you read the letter A, right? What about the next delta of Q1 and B? What do you say? Q2, yeah. And here's a small detail. Technicality should be the set of Q2, because what you're writing in every case should be a set. Because this is how the delta works for NFAs. You always get a set. Even if it's only one thing, you still write it as a set. And then delta of Q1 and epsilon, where can you go using epsilon transition? The answer is, again, Q2, like so, in a set. All right, and then you do the same business. Delta of Q2 and A is Q2 as a set. Delta of Q2 and B is the set Q2. And delta of Q2 and epsilon. What do you say for that? That would be the empty set. Yeah, there is no epsilon transition from Q2, so you can't get anywhere doing the epsilon. All right, this is the formal description of an NFA. Any questions about that? It's very, very similar to the DFA, so I don't think we need to make too big of a deal out of this. That's all right with you? All right, let's just briefly make a deal out of what exactly does it mean for a string to be accepted on an NFA in terms of its formalities. X is accepted by the NFA when, can we write this in terms of the set theory? Now, can I just, maybe on the side here, I will remind us, what did we write? In the case of a DFA, we wrote this, delta of Q0 and X, sorry, delta star Q0X is an element of the final states, right? This was for DFA. Now, unfortunately, for NFA, we cannot just write the exact same thing. This same statement doesn't make sense in the case of NFA. And it's because in the case of NFA, this delta star will be a set, not a particular element, right? The delta in an NFA gives you an entire set, not just a single element. And so it wouldn't make sense to say this set is an element of F. Instead, we have to say this set, I'm going to write it in sort of in words and then in a more formal set theory type statement. When delta star of Q0 comma X includes some accepting state. Right? Delta star of Q0 and X, this would represent the set of all the different places you could end up if you start in the starting state and do X. And what you want is just one of those, possibly more, but at least one of them has to be an accepting state. All right? Another way you can say that is some element of delta star Q0X is in F. Right? That's another way to say the same thing. And the best way to say this, at least the most sort of set theory language way to say this, is like this. This will look a little crazy. Delta star of Q0X intersection F is not empty. This means that there is some element which is in both of those two sets, right? I said the intersection is not empty. It means there is something in both of them, which is exactly the same as what I was saying up there. Some element of this one is also in this one, right? And so this is the fancy way to say that, what I put in the box there. Delta star of Q0 and X intersect F. It's not the empty set. All right. So this is the definition of the language of an NFA. So for an NFA, I'll call it M. The language of M is all the strings, X in sigma star, such that this thing that I just wrote, delta star Q0X intersect F, is not empty. This is the fancy definition for what the language of the machine is. All the strings, so that it is one of the things, one of the states you can get from that string is also one of the accepting states. All right? Any questions about all that? This is the end of the extreme formalism for today's class. We have 11 minutes remaining, which will consist of less extreme, less formal, more diagrams. All right, let's talk about this then. So that was the formalized description. But as you've gathered already, we don't usually think of things in those terms. We usually imagine the diagram. Something very nice about NFAs is, which makes them a little easier to work with than DFAs. NFAs can be easily combined together using Epsilon transitions And I'll give you an example. For example, if I have one machine, let's say M1, I'll call it, that looks like this. This is an NFA which accepts anything that starting with B, right? In this diagram, you can do B first, and then you can do whatever you want. So any string starting with B is accepted by this machine, which I call M1. I'll give you another machine, M2. This is any string which ends with B. Oh, sorry, I put the accepting state in the wrong place. I mean for this to be accepting over here. Sorry about that. This one accepts any string which ends with a B, right? It says when you start, you can do whatever you want for a while, but you got to end with a B. Anything that ends with B. Okay? Now what I said was NFAs can be easily combined using epsilon transitions. One way, it's very easy to combine these two machines sort of using the word or. So to make an NFA which will accept starting with B or ending with B, right? Now, you could think this through and make your own NFA from scratch for this, but actually, there's a cute little trick which allows you to create a new NFA out of these two that we started with, which does one or the other. And here's the trick. This, I suppose, this is a trick that you're going to be remembering eventually. Check it out. You make a starting state with two epsilons going out of it. And those two epsilons, they feed into the original two machines. So I'm going to paste in M1 up top. And I'm going to paste in M2 at the bottom here. All right. I have combined the two original NFAs with this little trick, which is you create a new starting state, which really doesn't do anything other it just gives you a sort of a base camp from which, if you want, you can go up here and do this one, or if you want, you can go down here and do this one. So I hope you notice this right here is my first machine, M1, and this down here is my second machine, M2, right? Very easy to combine together NFAs using this word or, right? You can't do this with DFAs. If you have two DFAs and then you want to create a DFA which does this one or this one, there is no simple way to do that. You have to basically rethink the whole thing from scratch. But NFA, much easier. Here's another trick you can do with NFA. Any questions about that, by the way? Another trick, we can also what's called concatenate. Concatenate, this is the operation that maybe you've heard this word if you learned some programming about. Concatenate is what you do with two strings when you stick them end to end, one after another. That operation is also called concatenating. So for example, to accept, what if I want a machine which accepts strings that look like this? X immediately followed by Y, where X is in the language of M1 and Y is in the language of M2. So in this example, it would say, M1 was things which start with B, M2 is things which end with B. What if I want to create a machine which consists only of strings where the first, that can be written in two parts, where the first part starts with a B, and the second part ends with a B. Right? This is called the concatenation of those two languages. Can anyone think perhaps how we could do that? Say you want to have some kind of a. Let's see that. I just got a YouTube notification. Did you see that? This is my daughter uses this iPad. I'm actually glad I turned off her text notifications because she gets them constantly from her. She's in 5th grade. She's in a group chat with everyone in her class, and the name of the group chat is drama followed by 3 popcorn emojis, and it's just constant. When I bring it to work, I see these things. I tell you, Juliana was blowing up this morning in the drama chat. She made a pretty bold statement that girls are loyal and boys are not, and that was controversial. Sometimes I wonder if I should jump in on that drama, but I don't. I try to respect my daughter's privacy. I only read them when they pop up. I don't try and go through and read the old ones. But okay, can anybody think of how could you start with these two things and maybe somehow like tie them together so that you get a machine? The idea is you want it to do sort of the first one in one chunk and then immediately followed by the second one in another chunk. Now this strategy is to make sort of 2 parallel branches. Can we do it some other way that gets you the one followed by the other afterwards? The idea is I would like to use these 2 basic diagrams and then maybe stick some epsilons or something. Yeah.
Could you just take M1 and then from the accepting state of M1 have an epsilon to like the starting state of M2?
Yeah, that's the idea. So we take M1 and then whatever the accepting state is, you make an epsilon come out and stick that into the starting state of M2. So this is a very vague picture, but in this example, it would look like my original M1 was this. Now, in the original M1, this used to be the accepting state, this one here. But I'm not going to make it an accepting state because I'm not done yet. In this particular setup, I want to send a new epsilon out of here, which ties into the starting state of the other machine. And then I just copy the other machine as is. There you go. All right, so what you see here is the M1, and then here's the M2. So this is another sort of cute little manipulation that you can do with NFAs. If you want to combine 2 DFAs in this way, it is possible, but not with any sort of cute trick. You have to just rebuild the whole thing, basically. But NFA, because of the epsilon transition, it's possible to tie them together in a nice way. All right? Yeah?
So you don't do the accepting state on that first M1?
Yeah, because you want it to be the language you're looking for are the things which begin with a string from M1 followed by a string from M2. So you don't want this to be accepting, or else you'd stop early. All right, we got 2 minutes. Let's just do one quick example. So this is something that may come up on the homework. If you are asked to make a fairly complicated NFA, make an NFA on this alphabet AB star, and I want it to accept when the length is even or when the number of B's is even. All right, this is kind of complicated. When the length is even or when the number of B's is even. All right, this is complicated, but when you see this word or, it means, since these are NFAs, you can think of the 2 things separately, make a machine for each of those 2 things, and then combine them with the epsilons like we did. So I'm going to think of this as the first one, like an M1, and then this is the second one, like an M2. And then I will think of each of them separately and then build the big one by combining them together. So just because time is up, do you mind if I just do this real quick? Length is even. You want basically 2 states where the letters just go back and forth. Every time you see a new letter, you flip back and forth. And these two states represent evens and odds, where it's accepting in the first one, all right? This actually is a DFA, but it still counts as an NFA, right? And then my second one, number of B's is even. I want to do the same thing, but it's only the B's that I care about. And the A's, I just let them do whatever they want. So this is M2. The number of B's is even. We've done each of those examples before. These are both DFAs, in fact. But anyway, my final answer is supposed to be this one or that one. And the way you just have to remember, how do we create the new one with the or, is that two parallel branching paths. So my final answer is start state with two epsilons coming out of it. And then we go into each of those machines. So what you end up with looks pretty complicated. And you will amaze your friends. Your loyal female friends. This is what you get. I noticed Frederick's reply was, well, I personally am very loyal, but I agree, Juliana, in general, boys are not loyal. That was Frederick's opinion. All right, I think that'll do. I hope you'll have a good weekend. Sorry for the technical difficulties. I'll see you on Zoom on Tuesday.
Yeah, like,